morning, good afternoon, good evening, wherever in the world you are. Welcome to this year's Virtual Cloud Foundry Summit. And my name is Simon Moser, and we will be talking about kubecf multi-cluster. I'm having with me Vlad Iovanov, who's a software architect at SUSE, and Enrique Encalada, who's a software engineer with me at IBM. We will be talking about Cloud Foundry and Kubernetes for the big leagues. And the question that we're trying to get at is what happens if you try to run a Kubernetes cluster with thousands or 10,000s of worker nodes? And the simple answer to this, everybody will tell you, don't go there, right? The reason why that is because most of the Kubernetes service providers out there have what they call size recommendations. So one Kubernetes cluster should not go beyond a certain limit. And usually that certain limit is described as a couple of hundred nodes at least if you want to use them for production workloads, right? We're totally aware that there are some experiments where Kubernetes clusters have been scaled up to thousands of nodes, but from a practical perspective, I think the recommendation is for most of them, a couple of hundred nodes is considered big enough. So while that is perfectly okay for a single tenant deployment, such as you can accomplish it with, Cloud Foundry kubecf today, or even with CF4Ks, we have problems when we're talking about large multi-tenant environments, such as the IBM Cloud Foundry service or the SAP Cloud Platform. Those are BOSH deployments today that are running thousands of BOSH cells, of Diego cells in BOSH. And they are not easily movable to a Kubernetes-based deployment. So in the next slide, my friend Enrique is going to give you an introduction to the use cases that we're solving.
Okay, thanks, Simon. So with these examples, like very large production Cloud Foundry environments in both IBM and SAP, I think that the question is quite relevant. It would be awesome if we could have like different foundries across different Kubernetes clusters. So just to give you a better idea of what does this means. This basically means that you have one Kubernetes cluster with your control planes, and then you can have different Kubernetes clusters with Diego cells. So this will be great, and some of the reasons of this is because we can address three limitations that we have now with a single cluster. One will be size restrictions. So basically, you will have eventually these massive multi-cluster deployments where you could have like n number of clusters just for your workload. Then we have isolation segments. Similar to what you do now with Diego cells, you can define a particular Diego cell where you would like to run organizations. Well, you can do that now, but across different Kubernetes clusters. And one of the last ones will be disaster recovery. This is also a really nice thing that you can achieve with a multi Cloud Foundry Kubernetes clusters, because you could define like one cluster on a particular region, and then you could have like a standby set of applications on a different region. So for example, if your workload is on US South and it goes down because of X event, you can still route all of the customer applications to US East. With this in mind, now Vlad is going to showcase a demo on how to do this.
Thanks, Enrique. So for this demo, we're going to start with a couple of IBM Kubernetes clusters. We have two of them deployed. One is a control plane, so all of the Cloud Foundry components like API, Diego API, and so on will run here. Basically everything except the Diego cells. And then here we have a second cluster, a second Kubernetes cluster where the Diego cells will live. So having these two setups, let's move to the terminal and we'll show how this works. So on the left, I'll show the current context. It's the control plane. And on the right-hand side, the context is the minions, so where cells live. So if we look at pods for both, we will see that on the left, we can find all of the Cloud Foundry roles, API, database, UAA, everything except a Diego cell. So applications will not be running on this cluster. On the right-hand side, we can see that we just have the Diego cell. So all the applications that we deploy will actually go to this Diego cell. And one more thing, harkening back to what Enrique was saying about isolation segments, we actually have an isolation segment set up here. It's called minions1. And this, obviously, this Diego cell on the right has a placement tag of minions1. So we can show that we have applications deployed here. We have app1, and we can actually curl this. And we get hello world back. So this looks easy, but what's actually happening is when we make a curl request to this application, we hit a load balancer, then we hit the Cloud Foundry router in the first cluster. Then that router goes through both subnets. So it goes through the gap of these two clusters and reaches the Diego cell where your application lives. So going back to the slides, we want to discuss a bit on how we did this. So we want to make it very easy for everyone to be able to deploy these advanced topologies. So it should be as easy as a Helm install with a particular flag set, and same for Diego segments. Now, as you can probably tell from this diagram, the control plane and cells have to talk a lot. There are a lot of connections happening. And for the gray arrows, all you have to do is set up Kubernetes services correctly. We have BOSH DNS capabilities inside kubecf. And with the correct external services set up, we'll be able to talk between the control plane and the Diego cells with no certificate changes. All the DNS names remain the same, and everything gets routed by Kubernetes correctly. So very easy. For the orange arrow, it's still easy. If you're using something like IKS or a hyperscaler, all you have to do is deploy your Kubernetes clusters on different subnets, as we're showing here. On the left, we have a 172.22, and on the right, we have a 172.23. For that orange arrow to work, all we have to do is make sure that the Go router can reach the Diego cell pod IP. And this happens automatically on IKS. If you don't run on a hyperscaler, you can use something like Cilium or Calico. These do a very good job, and it's easy to set up. Once you do that, the IP emitted by the route emitter will actually be reachable by the Go router. So with this setup, you can do what we've just shown, and that concludes the demo. Back to Enrique.
Yeah, all right. That was a really nice demo, Vlad. Thanks a lot. So summary and outlook. Running a kubecf or foundries across multiple Kubernetes clusters is working. I think the demo kind of proved that. One of the main things is we kind of tackle the three things we wanted to overcome, which is like the size restrictions. We wanted to make sure the isolation segments worked and also high availability. This piece of work or spike will be available soon in kubecf, and also the Irene support for multi-cluster is still in the works. As you may have seen, this was done just with Diego cells. I think that will be all for the summary, and now we go with Simon.
All right, so I have the pleasure to conclude this meeting again. So thank you all for listening in. I think we showed a nice, interesting twist on how to tackle large-scale and high available deployments of Cloud Foundry on Kubernetes. And if you have any further questions for us, please come and talk to us in the upcoming Q&A. And if you don't have time because you need to go to another session now or you need to do something else, we are always available in the Cloud Foundry Slack in the kubecf-dev channel. Interested in the code, there's a link to the GitHub. And with that, I'll just wish you a very nice rest of the conference and hope to see you all face-to-face again next year. Bye-bye.